So at some point or another, every DIYer is going to need a multimeter for troubleshooting electrical issues. But most DIYers don't know what all these multimeters are capable of and how they can make electrical installs and repairs a lot easier and faster. So in this video, I'm going to show you how to easily and quickly use the main functions on pretty much any multimeter that every homeowner and DIYer should know. I'm also going to share some tips to avoid some very common mistakes, and then I'm also going to show you how these functions can make all of your electrical installs, troubleshooting, and repairs a lot safer. So let's go ahead and jump right in. All right, so the two multimeters I'm gonna focus on the most in this video, and it's gonna be for differing reasons, and we'll get into that later. But this one over here, this is a Klein Tools CL440. I believe since the time that I bought this, this has now been replaced with the CL, I believe it's the 445, but pretty much all of the same functions. And this, of course, is a clamp meter that can do a lot of your standard multimeter functions by putting some probes in it. And then this one over here, this is the Klein Tools MM700. This one has now also been replaced by Klein, I believe, with the MM720. Again, pretty much all the same functionality. And of course, those of you that as the video goes on, you want to learn more about these multimeters, I'm going to have links for everything down in the description down below. So at any point, you can find those links, click on them, and you can check all of this out for yourself. All right, so as you can see, we've got a receptacle here. This is, of course, a mock-up board. This is technically a GFCI receptacle, but I have power going to this, so we're gonna demonstrate this as though it is a real-life scenario. One of the #1 things that DIYers and homeowners need to know how to do, and it is a pretty basic function, is know whether or not there is voltage going to the receptacles. And maybe not just that there's voltage going to it, but how much. It really just depends on what you're doing or troubleshooting. But what people use them the most for is to verify when they go to work on a receptacle or even a light switch or whatever you're working on, they want to find out if there's any voltage present before they start touching the wires and possibly receive a shock if the power is in fact not off. Well, that's where you can take your multimeter, and they're all going to have this function because voltage is one of the most common things that people check. That is a function that just every multimeter is just going to have. But on the multimeter, what you want to look out for when you're trying to find voltage is you want to locate somewhere on the dial. You're usually going to see a V. Now in this case, you see a V with a little squiggly mark is what it looks like off to the side here, and then underneath of it you'll see a straight line and some dotted lines. On this particular multimeter, just about everything voltage related is at this setting. That squiggly looking line is more like a sine wave, and it's representing alternating current, which is what your home has. So in order to find if something in your home has voltage, that's where we would put it over with that squiggly line there. And that's where then you can take your probes and you can insert one into each slot of the receptacle. Now, when measuring voltage, it doesn't really matter which one goes in which, but because red always represents hot, I like to put it in the line side anyways, which is this smaller hole over here. All right, so as you can see, I've now got my probes inserted into that receptacle, and we're getting 120.7 volts. And that's exactly what we're looking for. With this reading, it's letting us know 120 volts. That's exactly what it should be at your standard receptacle here in the US, unless of course it's a 220 like an EV charger or something like that, then you'd be looking for 240, but our voltage is good. If we were going to be trying to work on this receptacle, we'd be looking for this to be 0 or just some very nominal voltage there. So that's letting us know the power is still on. It would not be safe to work on this, so we still need to find that circuit breaker. Obviously, once we find that circuit breaker and it's turned off, which on this GFC, I'm just going to hit the test button to simulate that. Then, as you can see, it drops down to 0, and like I talked about, 0.322, very nominal. There's no voltage here. The receptacle is in fact dead, and there's no power going to it. So I'm going to go ahead and resupply power to it. And we're back to that 120 volts. Now, another great option if you're just looking for voltage mostly on outlets and you just want some basic multimeter functionality, that's where this Klein Tools ET270 can come in handy, because it's actually got a plug on it that all we would have to do is set it to the outlet function right over here. It's going to turn on, And then all you have to do is plug the plug into the receptacle. And some of you might be wondering, why is it showing 119 where the multimeter was showing 120.7? Well, right before I plugged this in, one of my fridges kicked on, and so it's just slightly pulling that voltage down. So still at 119, still well within range, but this is another great option that's out there, especially if you're someone that just wants to have one very basic meter. It has the plug-in outlet function, and then it also does come with probes to where you do have some multimeter functionality with voltage. See how it has two different ones, that's alternating current and direct current. And then you also have continuity and resistance, or when you want to ohm something out. And it also has a battery tester. So really just depends on what you want to do. But for those purposes, this is another really great option. And I just want to really quickly show you, I just unplugged that fridge. So if I plug this back in, we're back to getting that 120 volts. So just goes to show how sensitive all of these multimeters can be and let you know exactly what is present or isn't present when you do your tests. And when it comes to voltage testing, we just talked about alternating current, but now let's talk about direct current, which is what your batteries are gonna have, your car batteries. If you've got solar, you're gonna have direct current coming from those panels. So if you wanna do any type of troubleshooting with direct current, most of your multimeters are gonna come with that as well. So again, I'm gonna move mine over here again to that V. Right now, it defaults to alternating current. We can see that squiggly line there. I just have to hit select on this one. And then as soon as I hit select, it puts me into direct current readings. Same thing over here with my clamp tester, but again, on this ET270 that I just showed you that also has the outlet tester, you actually have a specific setting for the direct current. So it just depends on your multimeter. But just really quickly, we're gonna test this battery and see what it's at using direct current. So as you can see, this battery is at 7.97 volts. It is a 9-volt battery, and anytime you see a battery that's below 10%, so 10% would bring us down to more like 8.1 volts. So this is very close to that, but at this point, if you see this on a battery, it's probably time to just go ahead and replace it because it's definitely on its way out. As you can see, you can very easily get your DC voltage readings. All right, so this next function, this is actually one of my favorite functions and has actually come in handy so many times when troubleshooting different things, whether it's switches, relays, wiring, so many different things that this function can do, and it comes down to being able to test for continuity. So if you want to be able to test for continuity, again, it's going to depend on the multimeter that you're using. On this particular one, because it has so many functions, they often stack a lot of them like they did with the voltage. But if we look right over here, when you see that little symbol right there that looks like a little speaker, or it looks like audio waves that are coming out, that is going to be typically where your continuity setting is. And oftentimes when you test continuity, it's also ohming things out and testing your resistance values. So I'm gonna go ahead, set it over here to this setting where you see that symbol showing OL, so it's obviously not showing any type of resistance or anything. Well, the way that this works is if I touch these two probes together, it's gonna make a noise. And that's letting us know that there is a small electrical signal being sent through one probe and being received in another. Where this comes in very, very handy is if you're trying to figure out, do I have a cut wire somewhere? Is my switch bad? Do I have an extension cord that internally, if it gets kinked, the wiring is damaged and it's cutting off my current intermittently? Whatever it is, this is gonna help you figure out if there's a breakage in the line somewhere. So, for instance, as you can see here, I've got a long piece of neutral wire here. So if I take one probe and put it on one end, and I take the other probe and put it on the other end, as you can see, and actually here, it's making that noise, which is letting us know that there is a connection there, there is no breakage in it, and so more than likely, whatever issue I'm having is not with this particular wire. But for me, where this has come in particularly handy is this is a perfect example here, diagnosing light switches. If you go to turn on a switch and your light fixtures or your lights don't turn on, then you need to start troubleshooting. And I always like to start with the switch because if it's the switch, it takes care of all of the issues. So if we take our standard switch here, now this is a a Decora model, but it acts the same as your standard toggle switch. It's currently in the off position. So if I take one probe and put it on the bottom terminal there, and I put the second probe on the top terminal, it's reading OL, which means it's not giving us any type of a reading. And as you can hear, it's not making that beeping noise. So that's letting us know there is no connection here. There is no continuity. Whereas when you flip a switch, that's what it does. This is basically a gatekeeper that then takes the current from one side and puts it to the other. But if I go ahead and I turn this switch to on, and I take my first probe, put it on that bottom one again, take my second one, put it on the top, now we've got that audible noise. We're getting an ohm reading, and it's letting us know that we're getting continuity here, that there is in fact a connection. Where this came in handy for me, and I made a video on this, on how to diagnose bad light switches, this particular switch, when I turn it on, nothing would happen. So again, right now it's in the off position, so nothing should happen. I'll just put one probe on the top, one on the bottom, and as you can see, we're not getting anything. But when I turn the switch to on, and I do the same thing and put my probes on those terminal screws, you can see I'm still not getting anything. No sound, no ohm readings, nothing. So that is letting me know that this switch is bad. Internally, when I turn that switch to on, it's not making the connection. There's no continuity between them. So that is a perfect example of where this can really come in handy. It can also come in handy when you're testing relays and fuses. If your fuse is bad, you're not going to have continuity between it. So again, this is one of my favorite settings, continuity. It has helped me so many times, and it's one that a lot of DIYers do not realize that most of your multimeters have already built into it. But if it does, it can save you a ton of time anytime you're trying to make a repair and doing any type of troubleshooting. All right, so for this next function, it kind of piggybacks off of the last one. We talked very briefly about it, and that comes down to being able to measure resistance. And like I talked about a little while ago, that setting for me is over here where you see the little omega sign. That is for measuring your resistance and checking your ohms. Whereas again, on some of your other multimeters, it's just gonna have the omega symbol, and that's where that setting is. So I gotta flip it back over to here where we were just testing our continuity. And in this case, I can leave it on that continuity setting, and at the same time it's going to be showing me my ohm reading. And where this can come in really handy, and a certain example of this would be taking a look at this AC contactor here. There's a coil that goes between these two sides. This is a place where I've used this test personally. You can use them with water heaters. You can use them in a lot of applications. As long as you know what your resistance reading should be reading at, it can really help you a lot with any type of troubleshooting. And a lot of times, to find out what that resistance reading should be, you can usually find that somewhere on the data sheet of whatever it is that you are testing. And for me personally, I have found that AI can be a really big help as well. But when it comes to like AC contactors like this one here, as you can see, there's this coil on the back, and it's connected to this right here, and then on this side to this other one that's identical here on the other side. These are terminals where some spade connectors get connected. So I've got it on my setting there. All I need to do then is take my probes. I'm going to put one of my probes over here on the left side on one of those terminals I showed you. And then I'm going to take the second one, put it to the other side. We're also going to get a continuity audible reading as well, or at least we should. And it's also going to display our resistance. So I'll go ahead and test it. There's that sound that we're getting the continuity. So we know we've got a connection. And we're reading this out at 10.4 ohms. So in terms of an AC contactor, that coil that's on the back here is still in very good condition. Around 10 ohms, and it really varies on the contactor. The smaller they are, of course, the smaller the coil can be, lead to more resistance. So again, that's where that data sheet's gonna come in handy. But as long as I'm looking at 10 ohms, even all the way up to around 20 ohms, then for the most part, I know my coil is good. Now, what's funny is this contactor is actually completely shot. And if you can tell what's wrong with it and leave it down in the comments, I'll give you bonus points. But in the case of the coil, as you can see, it's in perfect condition. And that's where this test can come in handy. When, again, you're testing like an AC contactor, maybe it's a water heater element, whatever it is, it can let you know if a particular part is still in good and working condition. So whether you need to replace it or not, and then also let you know in case it isn't, it'll let you know then that obviously that's the part that needs to be replaced. All right, so for this next reading, this one can come in really handy for almost every homeowner. This is an experience that pretty much everybody has run into, or every homeowner will eventually run into, at least for this particular example, and that's going to come down to what is called capacitance. And that is basically finding what the capacity is of whatever part it is that you are testing. Where in my opinion, this comes in most handy for homeowners is for things like your capacitors, your AC unit, your heat pumps, your pool heaters. There's so many different appliances that use these capacitors, and knowing how to read this can save you a ton of time and a ton of money, especially when it comes to your AC unit. These parts generally are anywhere from $10 to $30. If you want premium parts, obviously more expensive than that. Whereas if you have somebody come out and fix it for you, you're looking at, I have $300, $400, $500, and some people have even said up to $2,000 just to replace this very inexpensive part. So how does this work? Well, this multimeter is capable of doing it. I'd need to go back over here to that setting I've been on the last two. But if you're someone that wants to do AC work, I would really recommend getting a clamp meter. This one's obviously going to be able to read this as well. So for this test, even though this one is very capable of being able to test this, I'm going to show you on this clamp meter how to test for capacitance. So all I need to do is connect my probes, and same thing as on this meter. It's got a lot of the same settings. Got my omega, continuity, and then right here, this is our capacitance symbol. So I'm going to go ahead, flip it over to that setting. It's going to default to continuity and reading resistance. So I just have to hit the select button on this. I'm going to hit that until I see NF down here at the bottom. And what that is nanofarads. This particular multimeter and many of them that can read capacitance are going to do what is called auto ranging. So once it detects microfarads, which is what we're looking for with this, then it will tell you what that reading is. Now this is a function that not every multimeter has. If you have a basic multimeter, you will more than likely not have a capacitance setting. You're going to find that setting more so starting with some of your mid-range multimeters, and they're going to be pretty much on all of your more advanced multimeters like these are here. But again, if you're planning on doing some of this work yourself, this will more than pay for itself on the very first time that you use it if you have to replace one of these. So we've got our setting there. Almost every time on anything that you're going to be testing capacitance for, but especially these capacitors, it's going to tell you what readings you need to be looking for. So on this one, we're looking for 80 microfarads or within 5% plus or minus. They're all going to be different, so you always need to pay attention to that to figure out what it should be at. Now, this particular one just has 2 terminals on it. So this is just a single motor run capacitor. So this might be what you find in your AC unit, or you might find one like this, which has more than that. As you can see on this particular one, we have 4. This is not very typical though. If you have a dual run capacitor, you'll have 3 terminals. Either way, doing the capacitance test is going to be pretty much the same. All right, so with our standard motor run capacitor here, we just have the 2 terminals. All I need to do is touch one probe to each one of those terminals. And as you can see, it is reading 62.5 microfarads. And you know it's microfarads when it looks like it has a U and an F. Well, 62 is going to be well below the 5% of where it should be at 80 microfarads. So in this case, we know this capacitor is bad. If you're out of that range at all, it's time to replace that capacitor, and more than likely, it's the issue of whatever problem you're having. But that's how reading capacitance works. All right, so for this next reading and function that a lot of DIYers should know about and can come in really handy in a lot of instances, but in my opinion, out of everything I've shown you, would probably be the one that you will use the least. But again, if you do need to know it, this is a very important reading to know how to test for. And that comes down to measuring amperage. Figuring out how much amperage or current a certain device or circuit is using. So as you can see over here, that's what some of these settings are for. I will tell you right now, if you're using a basic multimeter and you want to be able to use probes, for instance, reading amperage can be incredibly difficult to do just depending on what type of situation you're trying to test. Because it's not as simple as just putting your probe in one place and then really closely, maybe that's where the other probe goes. A lot of times you're going to have to break the circuit, insert the multimeter in series so that all the current flows through the meter. For a lot of people and in a lot of situations, this can be just very complex and, in my opinion, also very dangerous to do, because in order to measure current, you have to leave the power on. And if you're doing some of the things I'm talking about in order to make this happen, a lot of times it's really not a very safe situation. So that's where the clamp meter really shines, and why I said earlier it'd be good to be able to have both both of them because this clamp meter is not only incredibly accurate, it's also very easy to check amperage, and it's also much safer. So I'm just going to really quickly show you how to do that using this clamp meter because, again, unless you're a professional, I don't really think you should be trying to test it using a standard meter with probes. All right, so in order to demonstrate this, I'm going to use my Medea U-shaped window AC here. You can see I've got it on, the air is blowing, and if we look right down here, this is the power cord that's supplying the power to it. So in order to do this test, what we're going to be looking for is this setting right over here. You see the A with, again, that little squiggly mark or sine wave. That's for amperage alternating current. So I'll go ahead, put my setting over to that. And so now we're ready to read the amperage of whatever it is that we're wanting to test. So all I would need to do typically is, let me just push this camera down a little bit so you can see, is take my clamp, open it up, put it around my wiring, and then get my amperage reading. But as you can see, we are not getting a reading whatsoever. It's reading 0. And so you might be wondering, why is that? Well, the problem is, since I'm putting it around the power cord to the AC unit, inside of this cable here is not just the hot wire that's supplying the current, but the neutral and the ground are in there as well. And when they're all combined together inside of the clamp, you're not going to get a reading. They cancel each other out. So you need to find a way that you're able to separate those wires and get it around that hot wire to get your amperage reading. So I'll just really quickly show you a couple of different ways that you can go about doing that. All right, so back over here at this receptacle, I've got it pulled out away from the wall. This is one way that we can go about getting our amperage reading on whatever it is that we're trying to test using this clamp meter. So we want to locate the hot wire that's in behind here that's supplying the power to this receptacle. I've already got my meter set to that amperage reading that I showed you just a moment ago. So all I need to do then is get my clamp around my feed wire. And as you can see, it's showing we've got 60 hertz, which is what we want to see. And then we're also currently getting around 5 amps of current draw for the AC unit. And now we're down to 4.2 amps, and I can hear the fan has decreased some, so that is why. So anyways, that's one way to get your amperage reading on whatever it is that you're wanting to test. Just pull the outlet out away from the wall, put the clamp around the feed wire, and you're going to get your amperage reading. I was never in danger of touching anything hot here because I was able to just use the plastic clamp to then wrap it around the wire. I wasn't messing with any probes, and my hands really didn't need to get anywhere near it. So that is one way. Another great way of being able to check this with the clamp without having to take any of this apart is by getting one of these splitters right here. Again, this one in particular is made by Klein. As you can see, we've got our cover plate on and everything, so we're not inside of the box, but this splitter just gets plugged into the receptacle and we can get our reading that way. But some very important information to take note of before we do this is you'll see right here on the side, this is our hot side, this is where we're going to take our measurement. It says times 10. What that means is the reading I'm going to get on my screen is going to be 10 times the actual amperage amount that is running to whatever it is that I'm trying to test. And these can only be used on a maximum of a 15 amp circuit, which that's what this is. So I will just go ahead, plug that splitter in. Now that I've got the splitter plugged in, that's when I'll take my cord for my AC unit, plug it into the splitter. You can hear it just turned on. And then I can take my clamp multimeter and I want to attach it to one of these two sides. I always like to put it over here on the line side for me personally. So I just open my clamp up, put it in through the hole in the middle, and then put the clamp around it. Now, as you can see, it's only showing 1.8 amps. It should be a multiple of 10. Well, that's because the compressor hasn't kicked on yet, so we'll just give it a little bit of time. All right, so I just heard the compressor kick on. As you can see, now it's reading at 57 amps. But again, we need to divide that by 10 because it's being multiplied by 10 with the splitter. So if we divide this by 10, we're getting really around 5.4, 5.3, 5.2 amps. You get the picture. And now we're getting back into that zone where we were earlier in around that 4.5, 4.4 amp range. So again, another fantastic way, even safer way and easier way of being able to test the amperage of any particular device that you're wanting to test. Now these splitters can be purchased separately, or a lot of times if you buy a more advanced multimeter like this one here, a lot of times they might have it already included with it. Whatever the case is, if you don't have one already, I would highly recommend picking one up. They aren't terribly expensive, and as you can see, it can really make life and testing a whole lot easier. So I use my multimeter for situations like this, but a lot of times where I use this even more is out at my AC unit. I'm able to check the amperage of my compressor, whatever the case may be. As long as you can separate out that feed wire, you can figure out just how much current any certain device is using. So that's for the multimeters. Of course, there's also devices out there like this that you can just plug in. It'll tell you everything you want to know. If all you're wanting to do is test out certain devices, it'll tell you exactly the wattage. It can even figure up your approximate cost of the unit. So these exist as well. But since this video is about multimeters, we're going to leave it just at that. But like I mentioned earlier, for your convenience, I will have links for all the different testers, the clamp meter, my more standard multimeter. I'll also have some basic multimeters, the outlet tester that's also a basic multimeter, and just all of the tools and everything you saw in this video. I'll have links for all of it down in the description down below. So when you click on those links, it will take you directly to whatever you clicked on so you can check them all out for yourself. So really quickly, for me personally, when it comes down to being prepared for any electrical projects that might come your way, in my opinion, it is always best to have different types of multimeters and testers like I showed you in this video. However, if that's just not in the cards and you don't want a bunch of different testers, then ultimately it's going to come down to you as far as what you think you're going to need the most as far as capabilities and functionality. Well, I did a video fairly recently where I compare and contrast different types of multimeters and testers. I take a look at their different functionality, capabilities, where they might be used best, and ultimately who might benefit the most from each one. But I also did one recently on different grades of outlet testers ranging from basic to very advanced diagnostics. So if you'd rather check that out, then you can do so just by clicking on this one right down here. But I hope that you found value in this video, and if you did, if you could do me a huge favor, hit that thumbs up button right down below. And of course, if you have any questions or comments still, you can leave those down in the comment section. And I'll catch you all in the next one.